Alright, let's pick up another example here. Sine of 34 degrees times cosine of 56 degrees plus sine of 56 degrees cosine of 34 degrees. Now, we have identities or we have the angle theorem, but this is just kind of a big mess as in and nowhere to start with. First of all, this one's sine, this one's cosine, and then this one's the reverse. This is sine of 34, sine of 56. So they're in no way any kind of like term or anything trig related that we can use in this case. So the first thing we want to do is see if we can at least match these up to be consistent. So possibly rewrite this one. If this one's sine, maybe try to get this one as sine. And then over here, maybe we try to get these two to be the same. And since we've used the other one over there, we'll try cosine. So let's just try some things out and see how things work. We're going to leave this one alone. And I'm going to use my complementary angle theorem to rewrite cosine here. So this would be sine of 90 minus 56. And don't be discouraged. In some cases, there's a little bit of trial and error with some of these, as in what to try. But if one of your identities don't jump out at you initially, you're going to start with some type of complementary angle theorem. And over here, so on this side, we worked with this one, and on the right side, we're going to work with this one. So if I rewrite the one in red with the complementary angle, with our theorem, it'll be cosine of 90 minus 56. And then times the cosine of 34, that's still there. Okay. And like I said, this isn't the only way to solve it. You could have done the complete opposite of that, but it's a little bit of trial and error sometimes. Sine of 34, I'm just going to bring down. But what happens here? What's 90 minus 56? Sine of 34. So I am liking that these match up. Now, if I worked it another way and something wasn't matching up or looking like it was going to simplify or reduce, I'd start over and try something else, But here, that's nice. What about this side? Cosine of 34 degrees times the cosine of 34 degrees. Well, because these are the exact same trig function in the same degrees, I can multiply those together and it would become what? Sine of 34 degrees squared, right? What about the right side? Cosine of 34 degrees squared. So tell me what you know about an identity with sine squared theta plus cosine squared theta equals 1. Now, I purposely led you through this in this manner, but, I chose to do the complementary angle theorem of this one, and then over here, this one. But if I would have just tried cosine over here and cosine over here, I would have come out with something that wouldn't have given me something that simplifies nicely. That's what I say. Just kind of trial and error. You'll fight your way through it. But the more you do these, and always keep the end in mind. You're either using a theorem or you're using an identity. So if you're trying to manipulate it so that you can hit one of those, you'll get better and better at it as you go. Okay, so now we're going to take a break from that and we're going to go back to using some right triangles to solve. Just to remind you, we have this is a right triangle. This is angle. The capital letters are angle A and angle B, and opposite of angle B is side lowercase b, side lowercase a, and of course opposite the 90 degree is the hypotenuse C, which is the longest side. And we know that in triangles, a squared plus b squared equals c squared when we're looking for missing sides. For angles, this may be a little bit new to you. Angle A plus angle B must equal 90 degrees. Now, why is that? How many degrees is in a triangle? 180, right? And this guy right here says that this angle is 90. So how many degrees is left between the other two? The other 90, right? So that's where this comes in. So we're going to use this information, so jot that down and recall to work the next few examples. Okay. Given the information, they'll give us some description of the givens, and then we're basically to find all the other missing information. So let's just label what we have first. We have side B. Now side B is 7. So angle B is going to be 30 degrees. All right. I'm going to go ahead and start first with just my angle. So I'll say, remind myself that A plus B is supposed to be 90 degrees together. So to solve for A, that would just be 90 degrees minus B, right? And this one's easy to just do in your head, I know, but let me just leave the paper trail for you. So angle A is going to be what? 60 degrees, right? Because then I would, and then double check to make sure all this adds to 180. So 30 plus 60 plus 90. Right there, that's one piece of information that we were asked to solve for. So I'm going to box it. Okay. Now, these sides, typically Pythagorean theorems work very nice when I have two sides and only missing one. In this case, I have two missing sides. So I have to choose which trig functions are going to help me solve for that. Let's just consider the first one. Sine of theta. What's the sine of theta defined to be? Opposite over hypotenuse, right? So opposite over hypotenuse. Let's just look at that. Sine of angle theta. This is the one that was given to me. Sine would be opposite over hypotenuse. Okay. So let's do sine of theta opposite over hypotenuse. So it gives me one given and one thing that I don't know. What is going to be the angle that we're using? 30. So opposite is 7. And what's the hypotenuse? We don't know, right? So we're just going to let that be hypotenuse. Okay. So let's cross multiply this algebraically, and so we will get h times the sine of 30 is equal to 7. And how will we solve for hypotenuse? Divide both sides by the sine of 30. Whatever you do to one side, do to the other. Sine of 30 degrees. Okay. Now go ahead and calculate this and tell me what you get. And that should be 14. So hypotenuse is 14. Let me put this answer. Actually, I'll put hypotenuse equals 14. So h equals 14 units, whatever the units would be declared. So here we also have options. We can now use Pythagorean theorem, right? But Pythagorean theorem uses a calculation that I made, and if I made a mistake on that 14, then I'm automatically going to miss the next one too. So a more definite way to do this is to find the other trig function that allow me to use this given and this unknown. Which trig function would do that for us? What is opposite over adjacent of 30 degrees? Which trig function is opposite over adjacent? Okay, good. So the other thing we want to do, opposite over adjacent. So that would be the trig definition of tangent. So tangent of 30 degrees, opposite is 7. Adjacent, we don't know. We're just going to let it be lowercase a. And just like we did over here, we'll denote right here, I should do this for cross multiplication. So a times the tangent of 30 is equal to 7 times 1. So this is just going to be a times the tangent of 30 degrees is equal to 7. To get a by itself, we'll divide both sides by the tangent of 30. We'll put this in our calculator. Make sure your calculator is in degree mode and find that a is going to be approximately, let me make that approximate, 12.12, round it to 2 decimal places, approximately 12.12. Okay, and so let's just make sure we found everything. We found side A, found side C, and we also found which side C is the hypotenuse. I'll go ahead and change that to C just so it looks consistent with how it was presented. C is the hypotenuse side, and we found all our information.